Hi everyone. Today I'm going to talk about section 10.3, simplify radical expression. So in this section, mainly we're gonna learn about how to simplify the radical, right? Um, so in order to simplify radical expression, you must learn about the Proc rule for radical expression and the quotient rule for the radical expression. Um, in Proc rule for radical expression, you can see that you must have uh, two radical that, the radical that have the same index. So we let A be a real number that's root n of A and root n of B are both defined. And then you can combine the Proc rule from two or three or more, become only one radical expression. So as you see over here, right? Similarly, quotient rule can be the same, but you have to remember that for Poiret rule or quotient rule, you can go either way. You can split or combine. So for the Poiret rule in here, you see the right to the right way, it is combined from two radical to become one, and go back to the left is from one radical, you can split it to become two. Okay. For quotient rule, mostly we're gonna apply it by split it, but again, it can also combine, become only one radical for the same index radical of the top and bottom. So but in quotient rule, you have to make sure that the b is the bottom denominator has to be not equal to 0, because that's going to make it undefined. Okay, so let me have an example about multiply in radical expression. Let's see. Sorry. Say multiply. Let's say a square root of 5 multiplied by square root of 20. Okay, so you can see that in here you have two square root, right? And they multiply each other, and because they are both square root, so they have index as 2. So then you can combine it. We're gonna be square root of 5 times 20, and that give you 100. Square root 100, you use calculator, or you know that it's going to be square root of 10 square, going to be 100, will be 10. Okay, so let's have another example. Let's say cube root of -3 multiplied by cube root of 9. You will have what? Same index. So you can just have -3 times 9 cube root of that. Gonna be cube root of -27. And if you know that -27 could be rewritten as -3 to power third, then you can have answer at -3. Oh, actually, you want to okay. Let me circle the answer. So you see, let me see what you, let's say square root of 5 multiplied by cube root of 2. No, let's say 8. No, that you do is 6. Okay. So can you do this multiplication? No. Or you say you can. I cannot do multiply because they don't have the same index. Okay. So so that's the reason why you cannot do this one. Okay, so let's move to example number 2. That's multiply radical expression containing variable. Okay, so A, let's say square root of x multiplied by square root of x third, x over third. Then because they are the same index, I can rewrite it as x times x power third. And if you remember the per rule for the power, you're gonna have x times x power third gonna be rewrite as x over 4, right? 3 plus 1 plus 3, 24. And you can know that it's actually like a square root of x square, everything power square. That's gonna be equal to square, x squared. Okay. So now let's have problem B. Have let's say fifth root of 2x over y multiplied by fifth root of 16y over x. Okay. So we have the same index radical. Then we can apply the Poisson rule for the radical and have 2x over y multiplied by 16y over x with the fifth root over here. And when you do multiply inside of the radical, the radical, you know that this is the rational. These two, the product of the rational inside of the radical, you can cancel the common factor between top and bottom. So y and y gone, x and x gone. Okay, and then now what you have is fifth root of 36. So no, I'm sorry, 32. Fifth root of 32. And fifth root of 32 can be write as 2 to the power 5. And then that should be equal to 2. Then right, let's circle the answer. Okay. C. Okay. See. Let's see. Let's say, let me see. I'm gonna use square root of 5. No. Cube root of x. Let's do that. Multiplied by cube root, 4 root of x. What should I do for this column? You actually cannot do product for this one. Can you? It have different index, right? You see that. But for the radical, it could be different a little bit. Change it to be, you can change it to be rational power form. As you learned in previous section, x to power third can be rewritten as x to power 1/3. I mean, cube root of x can be rewritten as x to power 1/3 multiplied by x to power 1/4 because the 4 root. You can rewrite like that. Okay, and if you want to combine this, you can have simply as x to power 1/3 plus 1/4, and that can be rewritten as x to power 7/12. So this, if you want to change it to become radical, it can be rewritten as x to power 7 root 12. So note that you can combine the different index radical by changing radical form to be exponent form. Let's see. Exponent form. And apply power rule. Okay. So let's have some more example for that. 3. So multiply radical with different index. So you have, let's say a square root of 5 multiplied by 4 root of 5. And then you have, how can I do this one? You cannot multiply radical like I said before. But what you do is you're going to change it to be the power form. So 5 to the power 1/2 multiplied by 5 to the power 1/4. And you're going to apply the power rule for this one. So you have simply put 5 and then different power. So just put 1/2 plus 1/4, and then you have 5 to over 3, 4. And if you want to rewrite it in the radical form, gonna be 4 root of 5 over 3. So both of these should be okay for the answer. B. Say square root of y multiplied by cube root of x. No, that okay. Let's do this. So they have different index, right? Different index. Noted. Different index and different radicand. So I cannot combine. Okay, so for this problem, you cannot do anything else. Okay, let's have the last one as say square root of x over third. Let's leave it as multiplied by cube root of x over 2. What are you gonna do? So they have different index. Okay, but what about the radicand? Radicand have same base as x, right? Which they are using x here, right? Even though it's in this in the right hand side and the second radicand, you have x squared, but it's the base is still x. So you can convert it to be power form as x power 1/2 multiplied by x power 2/3, and then combine it. It's going to be x power 36 multiplied by x power addition with, or I can rewrite as 1/2 plus 3/3 first, and then 1/2 plus 2/3 going to be what? 36 plus with 4/6. It's going to be 7/6. X to the power 7/6. So that should be the answer. Or you can rewrite as use a color. Root 6 of x power 7. That's another answer in radical form. Okay. So let's talk about quotient. Example number 3. Simplify um, simplify quotient. So we have a square root of, no, not square root, third root of 5 to the power 8. Can you do anything for this one? 5 over 8. You can't, I mean, you can't simplify for the 5 over 8. But think about, we're going to split it. So you have cube root of 5 divided by cube root of 8. So you have top just stay at cube root of 5, but the bottom, you know that 8 equal to 2 to the power third. So you have cube root of 2 to the power third, and you have cube root of 5 divided by 2. Okay. So now let's have another column. Let's say B 4 root of x over 16. I can rewrite it as in the radicand x over 16, you can't do anything, right? So you what you do is you need to split the radical as 4 root of x divided by 4 root of 16. And you know that the 4 root of 16 can be rewrite as 4 root of 2 to the power 4. And now you know that answer should be 4 root of x power 2. Okay, circle the answer. Okay, so C, you have square root of 40 divided by square root of 10. All right, can you do square root 40? That could be a problem. You don't, it's not easy to, there's no number that multiply it with itself to equal to 40 and also 10. So what you're gonna do for this problem, I would love to combine these two radical because they have the same index, right? Which is 2. So I have a big square root of 40 divided by 10. And I'm gonna simplify the radicand first as square root of 4 over 1, right? 40 divided by 10 is 4 over 1. Just actually, I didn't divide, just 4. 40 divided by 10 is 4. And then, square root of 4 equal to 2. So sometimes you can see like, oh, even though at first is it looks like you can't do anything, but when you combine or when you split it, it could be easily to simplify, right? Let's have another, say, cube root no, let's not change. Square root, I don't need to have number 2 of x squared of y divided by square root of y. Okay. So in this in this column, I see that the top and bottom have y. But the thing in here is the bottom have square root y, top also have square root of x squared y. So I would like to say just gonna combine the square root because I have same index. So I have like square root of x squared times y over y. Is that okay? Anytime you see like top have a square root, bottom have square root, or same index radical, just combine it and see if you can cancel something. Okay, so now you can see like, oh, I have y and y common, just cancel it. So I have now it become x squared, square root of x squared. What is that going to be? It's going to be absolute value of x. If you remember you remember the previous section about square root of x squared, it has to be equal to absolute value of x. Okay. So we have okay. Let's talk about simplify. Okay, let's talk about simplify. Okay. Okay. So let's move back to the simplify. Okay, so you see that mainly in this session is we try to simplify radical with n root. You must remember that you have to follow two steps. Step one is find the largest perfect n power factor of the radical. And then step two, you're gonna factor out and simplify this perfect n power. Okay. I also provide some example in the right hand side here, such as square root of 12. You can rewrite it as 4 square root of 4 times 3, and then apply the product rule. You can split it. You have square root 4 multiplied by square root 3, which equals to 2 square root 3, because square root 3 cannot factor anything. Similarly, for the cube root of 81, you can rewrite it as cube root of 27 multiplied by 3, and then is applied product rule. It's going to be cube root of 27 multiplied by cube root of 3, and it's equal to 3 times cube root of 3. Okay. So similarly, you can also do 4 root of x power 5 by power rule like I show you. But remember that at first you need to follow with two steps over here. Find the largest perfect n power, and then factor out and simplify this perfect n power. Okay. So let's have example. This should be example 4. Okay, so let's move to we have example 4 already. Okay, let's move to example number 5. Example 5. Oops. Simplify radical expression. So let's say A. square root of 25x to power 4. And how can you do this one? Um, you should know that follow the two steps, right? The first one is what's that? Find the largest perfect n power factor of the radicand. Okay, so we can right away know that this one is perfect, the perfect square, and 5x square and square. So square root of that will be just 5x squared, right? Easily. Okay, so let's have harder one. Let's go with square root of 32 and to power 3. Okay, for this one, you must start with, you try to find the one that have larger perfect square factor. So largest perfect square factor would be 16 and n squared. Because why? Because you know that's 32 can be 16 times 2, right? 16 times 2 over here, right? So I use 16 because 16 here can be a perfect square, right? And then I have n can be rewritten as n squared multiplied by n over here, all right? So so now from 16n squared, I can be right as 4n. Everything squared multiplied by n, 2n. So from there, actually, you know what? I must to follow the second step as factor out the perfect n square. Okay, so you need to have factor out 16 n square times with the square root 2n, right? Note that 16n square is the largest square factor. Okay, so now you can have answer as 4n multiplied by square root of 2n. Okay, let's make it even harder with something such as c cube root of negative 16x cubed y fifth. So you can think about which one which is the largest perfect cube factor. Largest perfect cube factor. Okay, so I would have negative 8 because negative 8 multiplied by 6 multiplied by what's that, by 2 gonna be a negative 16, right? But negative 8 is a cube factor, right? What else? X cubed stay, okay, and y to power fifth. Now I'm gonna use y to power third because that is a perfect cube, okay, and then just gonna have the parentheses so I can, you know, separate it out. And now I'm gonna apply the pro rule to split it out at index 3, right? Cube root of -8 x cubed y cubed multiplied by cube root of 2. Oh, cube root of 2. All right, and then lastly, you're gonna have -2 times x times y multiplied by cube root of 2. I forgot the y square, right? Yeah, 2y square, because here is y square. Y square multiplied by 3 cube, gonna be y fifth. Okay, that should be it. Let's say have another one as cube root of 2a multiplied by cube root of 4a square b. Okay, so what now? If you try to figure out for each radical here to find the largest perfect cube for each radical, you don't want to have it, right? You see that for the first term, 2a, there's no one have a perfect cube, and 4a square and b also the same. So what I do is I'm gonna apply the product rule to combine or to multiply to this radical, because it has same index as 3. So I have cube root of 2a times 4a squared b. Right. So now you can have as cube root of 2 to power third, or you can if you write, you can write as 2 times 8, 2 times 4 is 8, and a to power third and b, right? And you and now you have you actually have perfect cube already. So you can factor the larger perfect cube as 2 third times a third and then cube root of b. So now you can have answer at 2 times a times cube root of b, and that should be the answer. That should be the answer. Okay. So, okay. Now let me combine things with another example. E. Let's say 4 root of 16x cubed divided by y to power 4. Okay, so how can I handle this quotient? Okay, so apply the quotient rule in here if you want, or I mean, I think the best way right now is apply the quotient rule, because you cannot cancel anything in the radicand, right? So I will have 4 root of 16x cubed divided by 4 root of y to power 4. So so from here you can have the bottom is just y, I know, But what about the top? The top, see the top have for root of 16 times x cubed. You must try to find the largest power 4 at the right again. So you see that 16 can be rewritten as 2 power 4 x power third, and you can factor it out. So 2 times x power third, and then y. So 2 to the power 4 of the for root of 2 to the 4 can be equal to 2 time with for root of x cubed stay divided by y. Gonna be the answer. Okay. So I'm gonna have, let's see, maybe one more example. Let's do one more example. F 5a squared divided by 8 square root of that multiplied by 5a power third times 2. Okay. I know that you may gonna think about, oh, you can cancel out a for this one, but that's, remember, in that case you're gonna have an absolute value of a for the first term, right? For the first radical. But I would not recommend that way. I would recommend that you're gonna combine to this radical because it have the same index at 2, and this product rule. So just so, and let's see you can cancel something. Okay, so you have big square root of 5a squared times 5a cubed divided by 8 times 2. So you will have 5 square, right? A to power 4 times a. I would like to write as a larger factor, largest square factor of a. So it's a4, and then 8 times 2 going to be 16, or 4 square. And now I would like to factor it out, and I have 5 square a square of square divided by 4 square. You see that? And I'm going to multiply by a square root of a. So now now you can have, as you know, just maybe top, and then top you're gonna have 5 square root of 5 square times square root of a square divided by square root of 4 square, and multiply by square root of a, and finally the answer has to be 5 times a times 4 divided by 4 and multiplied by square root of a as the answer. Okay. Oh, I forgot a square, right? Because a square, right? So just cancel out only one square. Okay. So I think, let me see if I have anything else to make sure. Okay, let's talk about, let me see. Let's talk about some special case. So let's say example, what is that? Example 6, right? 6. Have simplify, wanna simplify. Simplify. A square root of x minus 3 times square root of x plus 3. So you're gonna have what? You cannot simplify x radical here, right? You must think about combine by multiply product rule, right? So big square root of x minus 3 times x minus 3 plus 3. And in this case, you will think about the multiply binomial, right? This is a special form for different square form, which is a square minus b square will be equal to a minus b times a plus b. If we remember this form, okay. So from here, you can know that x in here is a and 3 in here is b. And you can rewrite it as x, square root of x squared minus 3 squared. Or you can rewrite it as square root of x squared minus 9. Okay, so in here, x square root of x squared minus 9 gonna be the answer. Okay, remember that this is not gonna be equal to square root of x squared minus square root of 9. Many students made that mistake. Okay, that is not true. Okay, don't make that mistake. And B, let's have square root of, no, cube root of x squared plus 2x plus 2 divided by, this is 3x, divided by cube root of x plus 1. So again, this is like a quotient radical, right? So you need to apply the quotient rule for the radical, radical. So by make a big cube root, and the top be x squared plus 3x plus 2 divided by x plus 1. Okay, so if you remember the way to factor, right? The way to factor, you need to think about factor the top. Okay, factor the top. So the top of the radical was x squared plus 3x plus 2. You apply the x method that I taught you before. I have a times c equal to 2 and b equal to 3. So two number multiplication equal to 2 and addition equal to 3. I'm gonna have 2 and 1. So I can rewrite the top as x plus 2 multiplied by x plus 1 divided by x plus 1 over here. Okay, so now you can see that, oh, you have the common factor between the top of the radical and bottom of the radical, which is x plus 1, and you can just have answer as the cube root of x plus 2 as the answer. This is a simplified form. Okay. So I have just finished 10.3. I'm gonna come to the next section and see you again later. So